Okay, so rational exponents, right? What's a rational number? Speak up. What's a rational number?
A rational number is a number that can be expressed as a product of two numbers. So one number over the next number.
Okay, let's call that a quotient. Just. It's all right. I know. It's the mic. It makes everybody nervous. Okay. So rational numbers. What do we commonly call a rational number? Fraction, right? Okay. So we're dealing with rational exponents or fractions as exponents, right? So let's start with this. What's root 9 times root 9? 9. Okay, now let's switch to exponents. What's 9 to the half times 9 to the half?
9 to the 1 or 9.
9 to the 1 half plus 1 half. So what does that kind of tell you then? What if root 9 times root 9 is 9 and 9 to the half times 9 to the half is 9? What does that say about root 9 and 9 to the half?
They're the same.
They must be the same thing, right? So it's the same way. So root 9, another way to express that is as 9 to the power of 1 half. Okay? Come on in. Now, what if, let's move down a little bit here. So what's, what's 9 to the third times 9 to the third times 9 to the third? What's that equal to? 9. So what must 9 to the third be? What did I do to it? I multiplied it by itself 3 times. What's another name for that? Cubing it, yeah. So this would be the cube root of 9. So when you cube a cube root, you just get the number itself, right? Okay, but what then? What about, let's extend the page. Wow, that extended a lot. What if I take the cube root of 8 times the cube root of 8? What's that equal to? I'm not cubing it, so.
8 to the power of 2/3.
So it's the cube root of, well, wait, let's call that 64, shall we? Which is?
8 squared.
Sure. What's the cube root of 64?
4.
4, right? We're going to get there, but you're just getting there a little bit ahead of me. Cube root of 8 times the cube root of 8 is the cube root of 8 squared. And so we actually write that, we can write that as 8 to the 2/3. Okay? Which could be, so this is the other fractional exponent, or it's not 1 over. So 1 over a number, when you raise a, when you use an exponent of 1 over a number, it means the root of what root? The number that's on the bottom, and the denominator is the root. In this case, this is still what root. This just says what root. And then this is what? Power. Okay, so we could think of 8 to the 2/3. You can think of it 2 different ways, really. You can think of it as 8 to the 1/3 squared. Okay, so we're doing power to a power, right? Which would be the cube root of 8 all squared. Right? Take the cube root of 8 and then square it. Or we can think of 8 to the 2/3 as 8 squared to the 1/3. Right? So I can write this either way. Right? And what I'm doing is I'm writing this as a product. So 1/3 times 2 is 2/3, or 2 times 1/3 is 2/3. Right? And in this case, this will be the cube root of 8 squared. So this is, 2 squared, which is 4, and this is cube root 64, which is 4. Okay. So either way, we're getting the same thing. Now, often you will find, I mean, if I have a choice, usually I'm going to do it this. I always do what root and then what power, because the roots you can do in your head often, right? But when you start raising things to powers and then having to do roots of it, you know, especially if it's a larger number, you know, you take 27 and square it, and then do the cube root of that, that's a little bit harder than doing the cube root of 27 and then squaring it, okay? But you have that option. So, well, let's try that with 27. Let's do a 27 to the 2/3. Okay, so what we're doing is we can change from a fractional rational exponent, and we could change this to what do you call it? Radical form, right? Using the radicand. So the cube root of 20, what's 27 squared? 729. And what is the cube root of 729? 9. Right? But optionally, of course, you could do it this way. Well, you could say it's 27 to the 1/3 squared, which is the cube root. I really left that out up here, right? I really should have said here that this was 27 squared to the 1/3. All right, which is off the screen there, but. And so this is the cube root of 27, and then we're going to square that. What's the cube root of 27? 3, right? This we know a lot sooner than we know A, how to square 27 without a calculator, and B, what the cube root of 729 is. Cube root of 27, that's 3. Squared is 9. Okay? So your choice as to how you arrange or how you handle a rational exponent, this is what they are. Okay? So in general, A to the m over n is equal to the nth root of A to the m, okay, or it's the nth root of A to the power m, okay? Either one, right? I mean, they're the same thing. It's just, do you want to take that power first and then take the root, or do you want to take the root first and then raise it to a power? Okay, my choice, take the root first, then raise it to a power. Okay, so what are we going to, yes, question?
So if you want to do, like if you want to root it first and
Yeah.
then do the power, do you have to put brackets around it?
Do you have to, well, so in what sense? I'm not sure that I understand. So if I have 512s to the 4/9, what would you like to do with that? Take the 9th root?
Yeah, take the 9th root.
So how do you want to write that?
And then
And now how do I indicate that's to the 4th power? Put brackets around and raise it to the 4th. All right. That's the simplest way, right? I mean, if you put that 4 in there without the brackets, then it starts getting kind of lost, right? People are now sort of unsure. Well, is that 4, like, so, if you write it like this. I'd, prefer you write it like that, right? It removes any ambiguity, right? Order of operation wise says do that. What is the 9th root of 512? Yeah, I knew that. So I chose it. So it's 2 to the power of 4, which is 16, right? I mean, the last thing I think that you really want to do is raise 512 to the 4th power. With calculators, does it matter? No, right? Because you could do, what's 512 to the power of 4?
Some odd large number that's 687194767.
Okay, so, yeah, big number.
Some big number.
Yeah, 687 million, or no, 6,871,000,000, I don't know. 68 billion, I don't know, it's like hard to read. Anyway, and then what's the 9th root of that? Well,
Um,
16 obviously, but
okay.
okay. But, and with a calculator, does it matter then? Well, no, it really doesn't matter if I raise 512 to the 4th, except I'm writing a huge number then. Okay, so, yeah, we're going to look at it as, well, I would rather do the 9th root of 512, which I do have a shot at figuring out without a calculator. Okay, and then raise that to the 4th.
Well, with the calculator, you can just raise it to the fourth nine.
Yeah, you can raise it to the 4/9. So on a calculator, if you do that, you go 512 to the power of, which is your upside down V or your caret. Put this in brackets, right? You need to put the exponent in brackets. Okay.
Otherwise it will say 2 power 4th. Then.
Otherwise, it'll raise it to the power of 4 and then take that number and divide it by 9, and you'll end up with 1/9 of 68 billion or 687 billion or whatever the number was. Okay, yeah, so what do we do? What do I do if I have a negative exponent? 8 to the negative 1/3. Yeah.
We have to put like 1 over that number.
Okay, yeah. So it becomes 1 over 8 to the 1/3, which is 1 over the cube root of 8. Okay, so you need to be able to translate back and forth, right? From radical form to exponential form, exponential form, radical form. And then you get 1 over 2. Okay, what if, pick numbers correctly here. How about 8? Eight over 27 to the negative 4/3. How are we going to handle this? Yep, Jay?
8 over 27, just if you flip it around, so that it's 27 over 8, then you can put it to the power of 4/3.
Okay. Now I'm just writing that so you can see that, right? We would never actually do this, but okay. But you can see that, I can write 8 over 27 as 27 over 8 to the negative 1. Okay, and in essence, then what I'm doing is I'm stripping the negative off of this. Okay, and this is still negative 4/3 here, right? So we wouldn't write that, right? We would go straight to, so just say, well, since I'm raising a rational expression to a rational power with a negative, then I'm just going to flip it and make that positive. Okay, and that becomes the cube root of 27 over 8 to the 4th power. What's the cube root of 27 over 8?
3 over 2.
3 over 2 to the 4th, which is 81 over 16, right? Okay. So hang on, let's... Okay, so let's take a look at number 90 on page 38. Page 38. Number 90. And the question is shipbuilding. The design of a new ship calls for the ship to be 300 meters long and travel at 12 meters per second. To test the design, a model 15 meters long is used. At what speed should the model be tested to the nearest tenth of a meter per second? Okay, so we got 300 meters long, travels at 300 meters long, 12 meters per second. And we want the model to be 15 meters long, and how fast should it travel? So, any ideas? Yeah.
I think the best way of solving it would to make a ratio. So 300 over 12 equals 15 over x, and then just go from there.
sort of how radicals came into this, right? Like, this is a question of radicals and why. Let's pause for a moment.